Assalamualaikum Dr. Ahmad Musin. This is our group member consists of Muhammad F. Ashraf, Muhammad Ashraf Fahmi, Muhammad Faris, Muhammad Haziq Safi, Muhammad Shafiq, and Raja Rahimi Mirza. We will present our project, Bearing Housing. Introduction. Bearing housings are modular assemblies designed to make it easy to install bearings and shafts, protecting bearings, extending their operating life, and simplifying maintenance. It also works as support for bearings. The bearing housing have different shape and size depends on the specific duty requirements such as load, speed and operating environmental conditions. Bearing housing divided into several types, which is plummer or split pillow block housings, non-split plummer block housings, flange housings, take-up housings, and tomb bearing housings. So, type, shape, and size need to be selected based on the different duty requirement. This is one of the example of bearing housing.
Problem statement. First, how the 3D modeling for bearing housing had been done after several typical issues happened before, such as incorrect choice of pillow block housing. Besides that, mechanical problem that happen to bearing and sheet but also can be triggered by housing. And next, does 3D modeling affect the simulation? Third, what type of G code had to write and generate? And finally, what is the machining process had been taken to fabricate bearing housing? For objective, first, to design bearing housing using CAD software such as Autodesk Fusion 360 or SolidWorks to develop CAD model. Second, to convert the CAD model into G code using Autodesk Fusion 360 for fabrication purpose. Third, to experience learn about quality control check process. And lastly, to implement familiarize with NC code and CNC manufacturing and fabrication procedure.
We choose the CNC machine model VMC X50L Vertical Machining Center to fabricate the bearing housing. It has 3 axis movement drill center in X, Y, Z movement capability. This machine is suitable for machining parts of automobile, small industry and so on. This is figure of CNC machine VMC X50L. In this slide, show specifications of CNC machine VMC X50L.
As seen here, the final product has been successfully fabricated using Fusion 360 software. This is the result after rendering. To manufacture this bearing housing, we assume as in the real machining. We will be using the VMC 850L Vertical Machining Center CNC unit to fabricate it. However, surface finishing cannot be achieved during the machining process on the bottom portion due to the clamp area. The surface finishing must be performed manually. Thus, we assume that we will be using turning machine TN50D to use for the surface finishing. Why did we choose to fabricate and improve this house bearing? It is because house bearing usually will facing defect that can be dangerous to us. For example, in the defective strut mount bearing that usually will experience driving a car's driving behavior, this defect can reduce driving and steering capabilities, extended braking distances, and increased wear of shock absorbers. There is no doubt that the defect would be perilous. Thus we want to develop a new design on house bearing by this awareness, which will improve mounting to be stronger. The bearing house can withstand high impact and heavy operation, and secure fit for bearing. As for the cutting parameters, the selection of cutting parameters has a significant influence on the consistency of machining, machining performance, and the instrument's life. Using various cutting parameters in the same process condition, the cutting will achieve different results. The process parameters chosen include spindle revolution speed, cutting depth, cutting width, and feed rate in the milling process. For the quality inspection, the bearing housing is designed to have the tolerance plus or minus 0.1 mm from the CAD drawing, as aluminium alloys nature has high in their thermal expansion. Since we are not doing the exact machining process, we cannot compare the final product's dimension to ensure the product dimension similar to CAD drawing design. However, we expect they might have slightly difference with plus or minus 0.1 mm due to the surface roughness. For further improvement, we should do the real machining instead of just having the simulation review, since it is crucial to compare the dimension of the final product. Other than that, we must make sure the generated NC code produced from CAM software can run well in the CNC machine, and also to identify the error or defect for the final product that might run properly in simulation but not in real machining condition.
As conclusion, this project was a successful as all the objectives were achieved, which is: first, to design any product using CAD software such as SolidWorks, AutoCAD and Autodesk Fusion 360. Second, to able to fabricate product using CNC machine by inserting G codes. And lastly, to experience learn about quality control check process. However, there are problems encountered in the process which give us the experience and knowledge more on how a CNC machine works, which all part of learning process. Thank you.